Hey class, Mr. Henry here with another video. Today we will be talking about how to calculate the speed of an object from its distance time graph. So in the previous lesson we started looking at distance time graphs and we were able to kind of describe the motion. So we knew whether an object was moving away from us, towards us, and then based on the steepness we could predict whether or not it was moving quickly or slowly. So today we'll actually talk about how you can calculate the speed and figure out how fast something is actually moving from the graph. To do that, we need to know how to calculate speed. And so here's the formula for speed. Speed is just equal to the distance traveled by an object divided by the time. So distance, basically how far the object has moved, and the time being how long it took to do that. So if we want to calculate the speed of an object from the distance time graph, we just need to be able to figure out those two things: the distance that it has traveled and how long it took to do that. So we could do that here in this graph. I'm going to look at each part of this graph one at a time. I'm just going to label them here. So first off, we can see there's part A. We can see that it is moving away from us at a constant speed. And then in part B, it stops. It's not moving at all. So the speed in part B, we know is actually just going to be 0. And then it keeps moving away from us again in part C. Seems to be about a similar speed. It's just almost about as steep. Looks like maybe it could be a little bit less steep. Let's start with looking at A here, though. So I'm going to look at the start and the end. But you could really pick any 2 points along this line, as long as it is a straight line. And basically what I need to know from this first point to the second point is how far did it go and how long it took. And it would be helpful to draw in a bit of a triangle to do that. So I'm just going to add that in here. So I just drew a little triangle under the line. This is going to help me figure out how far something went, as well as how long it took. Because we know that distance is recorded along the y-axis. And so we started down here at 0, and we have gone up to 5. So from 0 all the way up to 5 meters, that distance is 5 meters. Right, and you could count the squares or you could use the scale. If you're counting the squares, just make sure you pay attention to what the scale is. So this is going up by 1, so each line is 1 in this case. So that's 5 meters. We could also look at the time the exact same way, except horizontal. So the time, the scale is also going up by 1s. We start at 0 seconds and we end at 4 seconds. So that is a total of 4 seconds. And so if I want to calculate the speed for part A, so the speed is going to be the distance divided by the time. So that was 5 meters. And the time was 4 seconds. So I'm just going to have to do 5 divided by 4. 5 divided by 4 is 1.25. And since this was meters in seconds, it's meters divided by seconds, or meters per second will be our units for that. So the speed here was 1.25 meters per second. We can look at part B next, but part B is really easy because we know that it is horizontal, right? And so the distance is not changing. The distance was 5 meters the whole time, so it hasn't moved. So for part B, our speed is 0. The last part is part C. So I'm going to look at part C as well, and I'm just going to draw in the little triangle like we did before. And that way I can figure out the distance and the time. So the distance, you can see that we started here at 5 and we've gone up to 8, right? Or we've gone up 3. So the distance here is 3 meters. It's the same for the time, except we just look at the horizontal scale. We started here at 7 and we finished at 10. So from 7 to 10, that's also 3. So that's 3 seconds. So to calculate our speed for part C, we're basically just going to take our distance, which was 3 meters, and divide it by our time, which was 3 seconds. If I do 3 divided by 3, that's going to be 1. So that is 1, and the units are the same as before. They are going to be meters per second. And that's it. That's how you can calculate speed from a distance time graph. Obviously, this only works if we do have a straight line. So if we see something curved, something non-linear, that means the speed is changing, right? So we wouldn't be able to calculate the speed because it's not the same on that whole part. But in this one, we just had some straight lines, so we're able to calculate the speed using this technique.